Good morning and welcome to our Smart Safety webinar. We hope at the end of today, you will feel we gave you some valuable information to help you improve your safety and maintain your productivity. The agenda today will be the Smart Safety Life Cycle, safety devices, the Smart Safety app, and a Q&A. Please use the Q&A feature for questions. We will have moderators answering these questions live. We aim to partner with our customers to help bring them a safe and efficient environment. We are a single source for all your industrial safety needs. Meet the experts. Each location has at least one certified TUV safety technician on staff. You don't have to hurry and jot these down. We will have these back up at the end of the presentation. So let's start with what is a smart machine. A smart machine is connected, gives us real-time information, provides remote access, and is safe and secure. Here's a look at a smart machine architecture. Manufacturers are making smart devices and components that can communicate to the local controller. That local controller can now talk from a machine level up to a plant level and beyond to a corporate level. Along with the smart devices, safety products are becoming more advanced and communicate up the chain as well. What key business drivers do end users find useful? As OEMs, these should also be the drivers to think about when engineering new equipment. Reducing risk falls into these categories. If we can use smart safety on our new and existing machines in our plants, we can lower the risk of harm to employees and the risk to damage or waste product. This will reduce overall cost and gain profit. How smart are your current machines? Do they provide real-time diagnostics? Do they use contemporary machine safety techniques? How well do they improve operational efficiencies? Let's take a look at why we invest in safety. Some of the best in-class manufacturers develop safety as a culture, perform safety assessments and establish a formalized risk management strategy, and invest in technologies that improve both safety and productivity. SMC partnered with Rockwell should give you some comfort when working with us. We offer TUV certified professionals, experience with safety projects every year, and provide machine safety at the highest level. Not only are we certified, we offer classes to get you certified as well. SMC incorporates technical experience with industry knowledge to address your challenges, follow national requirements, and help you follow a proven process to reduce workplace hazards through review, assessment, and strategy. So why invest in smart safety? In 2016, the average cost of downtime equaled $260,000 per hour. In 2019, there were 5,333 worker fatalities on the job. Machine safety used to be cumbersome, difficult to apply or troubleshoot, and oftentimes less productive, which means they are often bypassed. The move in the industry is towards flexible manufacturing systems that leverage new technologies to drive overall system performance. The technologies include integrated safety solutions. Oftentimes, safety and productivity are viewed at two opposite ends of a spectrum. One might view safety as a legislation requirement that costs them time and money. Most think that safety causes increased labor rates, reduced machine utilization, and increased downtime. With a strong safety culture, compliant safety procedures, and contemporary safety technologies, best-in-class manufacturers have shown that they can help protect people and directly benefit the bottom line. SMC works to solve the typical safety problems encountered in manufacturing settings by designing solutions that integrate safety and machine functionality. Our process follows the safety lifecycle approach, which begins with the identification of risks or hazards. The safety lifecycle approach then takes you through the identification of system requirements, the design, installation, and validation, of the safety system and then the maintenance of the system. This model simply supports good design concepts throughout the life of the machine and safety system and represents the true integration of safety standards. Let's take a closer look at how Rockwell Automation approaches the stages of the safety lifecycle, beginning with the hazard or risk assessment. The first steps are the hazard and risk assessment, which is followed by identifying functional safety requirements of the machine. The assessment helps us later on in the design phase, so the designer has a basis for the solution. It will lead to correctly selected hardware. It will yield better safety solutions being implemented, and it will help make sure that the job roles can perform their intended functions. Conformity audits fall under this as well. Multiple machines plant-wide audit provides a high level of an analysis of specific safety areas, analyzes guarding and components that perform safety functions, e-stops, and safety devices and/or isolation devices are identified and labeled. Risk assessments offered by the SMC team, safety engineer or consultant, have limited customer involvement, typically just operations and maintenance. Gives you evaluation report, includes documentation of participants and identification of primary hazards or task, risk in, risk out rating, recommendations for safety improvements such as protective guarding, electrical safety controls, pneumatic and fluid power safety controls, the safety circuit performance requirements, and a photograph of a critical identified hazards based on a customer approval. The team-based risk assessments include all the features of the standard risk assessment and the following features. The team-based assessment facilitated by us by a safety engineer or consultant, your team of operations, maintenance, engineering technicians, cleaning, sanitation, and safety personnel provides input during the assessment. Basic risk assessment training, hazard identification during setup, normal and abnormal operation, sanitation and cleaning, maintenance under limited energy, and emergency condition. Report documentation includes all the elements from the safety evaluation, and this service can satisfy the risk assessment requirements of a safety standard such as OSHA, ANSI, or CE machinery directive. What do we look for in a conformity audit? Guarding. Are the machines properly guarded? That's probably number one. Lockout, tagout. Is there a procedure in place? Are e-stops in the proper locations? Are there any present sensing devices? If so, are they applied correctly? Here's a closer look at the deliverable for a conformity audit. We will score each area of the plant, make notes and recommendations, and we will educate the customer on what improvements are needed, prioritize the issues, and provide confidence on the existing safety program. The machine risk assessment identifies and evaluates hazards based off a risk scoring system. It creates the foundation for the next steps of the safety life cycle, provides the appropriate performance level, and shows the compliance to safety standards. This process serves as an effective tool for properly identifying and assessing the real hazards involved in operating a particular machine. A risk assessment provides a method for determining equivalent levels of protection when designing safeguards and stating OSHA's minor service exception. The process takes away the guesswork when estimating risk and prescribing safety system performance. Risk assessments is an active, documented process that can be filed and maintained for the entire life of the machine and serves as documented proof of your due diligence. Risk assessments establish the foundation and early framework for the design and implementation of the effective machine safety program. Team-based risk assessments, all the features of the standard risk assessment with the following additional features. Team-based assessment with an engineer or safety consultant, It includes your team of operations, maintenance, engineering, technicians, cleaning, sanitation, and safety personnel helps provide input during the assessment. You get basic risk assessment training so you can continue on your own if wanted. Hazard identification during setup, normal and abnormal conditions, or sanitation and cleaning or maintenance. We, along with your team, will help facilitate selecting a safety system that will reduce risk but maintain functionality. Then we will provide an analysis to show the change in risk after the solution is implemented. After the assessment, you now have an obligation to start implementing the necessary safety functions. The next step is the Safety Functional Requirement Specifications, or SFRSs for short. After the assessments are completed, we can use the findings to define the requirements specification for mitigating identified risks. This process takes into account all employee hazard points as well as collaborative applications. The SFRSs define the safety functions, guarding and controls needed to mitigate each hazard for compliance. Your involvement in this step, regardless if you did a team-based risk assessment or not, is crucial to confirm the acceptable risk and practicality to the new process. This step is important as we verify the remediation is practical, minimizes the impact to production, and evaluates any possible processes or work task changes. You will receive these specs to approve, and once approved, these specifications are the basis for the safety remediation design. Here is a sample of an SFRS deliverable. We describe each hazard event, then the required level after safety is implemented, how the operator will now interface with the machine, and a description of what should happen if a failure is detected or occurs. You guessed it, after the approval of the SFRSs, we designed the safety function. Using the SFRSs as the basis of design, we engineered to a specified performance level to help ensure everything is applied appropriately to protect personnel. Using Systema, we now design the appropriate safety systems, review the design for compliance to a specified performance level to ensure that your machine is properly equipped to protect personnel. Let's get a better understanding of Systema now. Systema stands for Safety Integrity Software Tool for the Evaluation of Machine Applications. A SIL, or Safety Integrity Level, applies to a safety function. The subsystems that make up the system that implements the safety function must have an appropriate SIL capability. This is sometimes referred to as the SIL claim limit, or SIL-CL. ISO 13849-1 does not use the term SIL. Instead, it uses the term PL, or performance level. In many respects, PL can be related to SIL. There are 5 performance levels. PLA is the lowest and PLE is the highest. Here are some links we use from Rockwell on a regular basis. We are going to throw these links in the Q&A for anyone interested in downloading or viewing these. You have a landing page for all safety references, an introductory guide to machine safety, and Safety Automation Builder is a free design tool to streamline your safety system design process. This is an example of the SafeBook 5. Functional safety is driven by both technology and standards, both of which evolve. The SafeBook 5 reflects these changes, providing a reliable reference to current practice. Safety Automation Builder helps us design to the specs generated in the SFRSs. The link to download this software will also be in the Q&A. Let's demo Safety Automation Builder now. First, we'll open up ProposalWorks. If you haven't downloaded this, you'll be able to download this from Rockwell's website as well. Let's go to Tools and Safety Automation Builder. Let's give the project a name. And the customer name, I like to use the line that we're working on here. Choose where we'd like to start. Let's assume we've already identified the tasks and hazards and we want to select products and define control. And let's keep everything at a PLD level, performance level D. Let's add a safety function. The name, we're going to start in the filling station. Let's do access control with trapped key. The logic, let's use a safety relay, and the output will be a safety contactor. Let's add a second safety function. Let's use access detection and guard locking. We're going to use the same safety relay and the same safety contactors. And let's do one more safety function. On this one, let's use presence sensing. We'll use a safety relay, but not the same one. I'll show you that here in a minute. And let's use a drive as the output. Let's save this. From here, we can edit the safety functions. We can import a layout of the image. Let's click Next. Now we get to design each safety function. In the input, let's pick a rotary switch. We will use ProposalWorks product configurator to design. We're going to use standard key coding. We're going to use a single key rotary switch panel mounted. And let's do 2 normally open and 2 normally closed contacts. Do we want to add the keys to the BOM? Yes. And let's use key code AA. Now we can accept. Let's move on to the logic. Let's pick a new guardmaster relay. We're going to use 2 dual channel inputs because we're going to use the next safety function on this relay as well. And we'll use 2 normally open outputs. And let's pick a 100C contactor. We're going to have 480 volts. We're going to use a 30 amp contactor, and the coil voltage will be 24 volts DC. We will use 3 normally opens and 1 normally closed, and we want to use standard auxiliary contacts. And we want to use the electrical load failure close as the Sistema application. All right, let's answer these questions to make sure that we meet the Sistema level we wanted. Are we in accordance with relevant standards to withstand the expected influences? Are basic safety principles being used? Is well-tried safety principles being used? Is a single fault tolerance given? And is the accumulation of faults does not lead to a loss of the safety function? Yes. Now let's select the appropriate measures from ISO 13849-1, which is also our PL level. Is physical separation between signal paths being used? Do we have diversity? Does different technologies or designs or physical principles being used? Under the design, application, and experience, is the protection against overvoltage or overpressure or overcurrent or overtemperature being used? And are the components being used well tried? Under the assessment, for each part of the safety-related parts of control system, a failure mode and effect analysis has been carried out and its results taken into account to avoid common cause failures in the design. Is training of the designers to understand the causes and consequences of common cause failure? Yes. And under environmental, for electrical or electronic systems, prevention of contamination and electromagnetic disturbances to protect against common cause failures in accordance with appropriate standards? Yes. And as the consideration of the requirements for immunity to all relevant environmental influences such as temperature, shock, vibration, and humidity? Yes. That gives us a total of 100 points. How much of that are we using? All of it. For both channels. And then let's pick the reason why. We're going to use fault detection by process. Now we can click done. All right. So for the second one, let's add a new device. We were going to use guard locking here. We can pick it from the product configurator, but I know which one I want to use here. I want to use the new 440G MZ. Yes, we're going to use the same one. If we didn't want to use the same relay, we could click add new device here. Now you can see we've used two functions on this safety relay, and we're going to use the same contactors. So yeah, I now have two functions there as well. All right, let's pick the last one. We were going to use a presence sensing device. Let's use the 450 light curtains. I always stick with the E's because they're the enhanced and they have integrated laser alignment, 14 millimeter for finger detection, and the place that we're looking at is about 41 inches. I like to use the universal plugins as well because both plugins are the same for the transmitter and receiver. Notice that it also goes ahead and picks our cord sets for us too. It's working now to build it into our bill of material. All right, logic. We need to add a new safety relay as we've used two functions on the other one. So let's use a single relay this time. One dual channel universal input and two normally open outputs. All right, and we decided we were going to tie this to a VFD. So let's pick a 525 now. 480 volts. And let's use a 3 horsepower for the conveyor that we're looking at. And we don't need a filter. Notice we can't hit accept yet because we need to decide if we want to add circuit protection. Let's not add that at this moment. All right, click done. And now we have designed all safety functions. If we hit save, it's going to save the bill of material for us, or we can hit generate documentation. Let's pick the documentation we want to generate. Since we didn't have a layout, we wouldn't pick those, and we would hit generate now. To save time, I've already done that for us. Let's take a look at some of those. Here's where it generated our full bill of material with our rotary switch, our key, our safety relay, our safety contactors, and the guard locking device. See below, it also got our light curtains as well, and our drive. Let's take a look at some of the documentation that it created. Here's the SFRSs. If we scroll down, we can see where the reference documents and how many revisions we had. It shows us the standards that we were able to use, and it shows us our safety functions. The access control trapped keys, the interlocking device, and the presence sensing devices. And then it breaks out each individual safety function for us. It also shows the safety assessment. If we would have done the assessment, we would have all of it here, including the machine and the affected people. Here again is our safety functions. And the Systema report. We can look at the Systema report now. Oh, we've got an X here. Something must be wrong. The filling station has something wrong. Let's look at it. Oh, it's under the output contactor. What does it say? It says, not all of the conditions of the chosen category are met. Please check the list of requirements in the category tab of the subsystem. Let's go to the category tab now. Everything's clicked but one. The accumulation of faults does not lead to a loss of the safety function. If a single fault is detected at or before the next demand upon the safety function, if this detection is not possible, an accumulation of undetected faults shall not lead to the loss of safety function. So let's click it now. Look, we went green, so we're good there. Let's look at this one. I bet it's the same thing. Sure enough. So now we're green all the way through each one. We just didn't have everything checked. All right, let's go back to the slide deck now. After identifying your risks through a risk assessment in step 1, defining the safety functions to minimize this risk in step 2, and properly execute the design and verification in step 3, you are now ready to move to the remediation phase of your life cycle. We can support in many ways if you want to execute this step, or we can deliver a turnkey project. Now that your safety is installed and operational, we can help maintain the safety system across the life cycle by offering other services, including employee training, revalidating, and scheduled safety audits. Now that we have discussed all 5 steps, we would like for you to know we can help with any of them, from prioritizing and assessing to design, implementation, and maintaining your safety system. So how do you realize these savings? These lockout tagout would be the first. These activities typically exhibit all or most of the following characteristics: short in duration, minor in nature, occur frequently, performed by operators or maintenance personnel, require minimal disassembly, represent predetermined cyclical activities, minimal interruption to production, occur even at optimal operating levels, and require task-specific personnel training. What about safe speed? The machinery service functions such as cleaning can be dangerous if they're carried out when machinery is operating, but they also are time-consuming when machinery must be shut down. Because of this, plant floor personnel will too often find a workaround to a machinery safeguard and service the machinery while it's running in an effort to save time. This equals a recipe for disaster. How about zone control? Using zone control, a specific area of your production process can stop or slow down while other zones continue to run at normal speed. This allows for operators or maintenance personnel to safely enter a zone to clear a jam, make a machinery adjustment, or carry out other tasks while the rest of your production processes continue as normal. Or how about diagnostics? Like any other part of your machinery, safety systems are subject to wiring faults, open gates, or other machinery events that require maintenance or repairs and lead to downtime. When these events occur, they can send operators and maintenance technicians into a scurry of trying to fix the machinery, and that begins with identifying the root of the problem. Diagnostics play a critical role in your design for recovery strategy. Controlled from a safety PLC, distributed safety I/O modules can be located on the machinery close to sensors and actuators. These modules do more than ensure safety functions are operating correctly. They also pinpoint the source of a stoppage on your safety system and more quickly guide technicians to an effective restart. Now that we have focused on the life cycle, let's take a look at how we can add the safety remediation but keep productivity high. The advent of integrated safety technologies that connect and or combine your safety and standard control systems has opened new doors to productivity. Integrated safety helps ensure the safety system has a far lower impact on productivity by improving machinery availability, reducing mean time to repair, or MTTR, and streamlining maintenance. Integrated safety is at the core of what's known as a design for recovery strategy, which requires that you treat safety events as normal, expected, and design your machinery to recover as quickly as possible. That recovered downtime translates to more production time for your plant, which accumulates throughout the year and can add up to a significant profit improvement. Consider a typical lockout tagout downtime event as illustrated above. A safety system that is designed for recovery can speed up or perhaps even eliminate some of the processes within a lockout tagout event. In this example, consider an improvement of just 1 minute to an entire lockout tagout process that averages 12 minutes. This improvement is about 8% of the current MTTR, but the savings add up over time. If the production value per minute equals $1,000 and you have an average of 8 downtime events per day in a 350 production days per year, your savings would amount to $2.8 million annually. Let's look at a couple applications. In the printing industry, safe speed can help an operator more quickly and safely clean the rolls on a printing press by reducing the speed and even the direction of the rolls. This helps shorten the duration of the cleaning process because the rolls can be cleaned continuously while they turn. It also can improve safety because the rolls are operating at a decreased speed and are now turning outward away from the machine instead of inward. Now there is no pinch point. In the food industry, in the event of a production issue, safe speed monitoring can allow an operator or maintenance technician to open a safety door and make adjustments, such as correcting a dispensing nozzle, while the production continues at a reduced rate. This can allow the operator or technician to monitor his or her adjustments as they're made, eliminating the need to continually shut down and restart the machinery for each adjustment until the issue is resolved. Now that we have looked at a few examples, let's take a look at some new technologies to make our machines smart and safer. We offer a broad spectrum of multiple safety inputs from laser scanners, light curtains, and door switches, most of which can now be put on Ethernet to save you installation and engineering costs. GuardLink connects safety components into a smart safety topology. This allows for simple installation with quick connects. Smart integration with devices linked with Studio 5000 with automatic diagnostics reporting, this eliminates programming. And this system is rated the highest safety solution of SEAL 3 or PLE. Remember, those two are different. GuardLink enables us to daisy chain up to 32 devices and 1,000 meters with no loss of safety rating. Through diagnostics, this safety system guides operators in identifying the location and reason for the demand for a quick recovery, leading to less downtime. Let's take a look at an application now.
In this scenario, scenario, we have multiple manufacturing lines with multiple guard doors, all connected back to a central controller. Over a period of time, issues may arise, such as vibration, causing an interlocked guard door to open slightly, thus stopping production. The control system will notify the operator that the line has stopped, but there will be no identification of the position or nature of the individual fault. Maintenance personnel will need to be called to troubleshoot with an aim of getting production back online. This could be time-consuming, resulting in lost production costs. If we look at the same scenario, but employ Allen Bradley Guardmaster safety relays and safety components, featuring GuardLink technology, you can access status information for the entire safety system. Connecting all the safety devices through GuardLink-enabled smart taps and standard 4-conductor cabling allows visibility of system status down to the individual guard doors and e-stops. If an e-stop or an interlock switch is operated, that individual safety signal will be sent to the Guardmaster safety relays. The relays are optically linked to each other, requiring no wiring for communication between them. Locally, the operator receives notification that there is a fault and will know exactly where it is located, so that he can correct it himself in the event of a minor issue, as shown here, or contact maintenance personnel for more serious faults. Ultimately, GuardLink not only minimizes downtime by communicating real-time diagnostics, but does so while significantly reducing wiring. In this
With the newest release of GuardLink 2.0, we now have the ability to use up to 3 zones or 3 independent channels using smart taps and on-machine mounting. Now we don't have to run the safety system all the way back to the control panel, only the power and Ethernet from the 432ES IG3 adapter, Ethernet adapter. All of this certified to IP69K, there's no worry of water or particle ingress. SMC Rockwell also offers supplemental offerings for the do-it-yourself company, from software that helps with each step of the life cycle to TUV training and corporate safety programs. Or if you want a hybrid of some do-it-yourself with support and service, we can offer that as well. One of our partners, Mark Dunwoody with Dunwoody Automation, has developed a software that can help you capture a risk or potential risk and follow it through to remediation. I will let him explain that to you now. Mark, are you there? I don't hear him, so I'll do my best to get through his application that he designed. The Smart Safety Manager app is a safety assessment tool that consistently captures the risk of an accident anywhere in your workplace, consistently ranks the risk of this potential accident on a quantifiable scale, and consistently tracks each risk to completion. We also use this whenever we go out to your facility and do a risk assessment. That's how much we appreciate this app. It's extremely easy to use, cloud-based tool that allows quick recording of the site assessment and all of the above into a single database. Instantly, everything is documented, prioritized, and managed consistently. Notice we can include near misses. It doesn't have to be just from a risk assessment. We can sort and filter and search for everything in the database instantly. We can email notifications and send status charts instantly. Live updates on break room monitors. We can track safe and unsafe conditions and see when they have turned from unsafe to safe through the remediation of that safety task. A turnkey task management and corrective action system that ensures effective tracking and timely closure of items. Your data can instantly show the number of accidents that you have prevented and a cost savings. We can also look at past due tasks to see which ones need more attention. The Smart Safety Manager also includes a behavior safety tool. We can launch a behavioral observation process or convert your paper system into just one afternoon. Immediately start mining your data and managing individual behaviors. No training is required. All of your information is documented, prioritized, and managed consistently in one place. One safety metric that everyone understands and everyone can be involved. Supervisors are trained in only 15 minutes. And when you manage with the Smart Safety Manager, your injury rates drop year after year. With only a few clicks a day, your safety assessment becomes a very sophisticated safety management system. You can use your PC, smartphone, tablet, or import your existing items. Your risks are evaluated and prioritized. They're assigned, tracked and managed, and you receive a safety improvement index. Like I said earlier, our goal is to partner with our customer to help them become more safe and efficient. We also offer more training and products in the safety field that may help you along the way. Let's check a few of them out. Some of the services offered by SMC are arc flash assessments, electrical thermal imaging, electrical insulated rubber glove testing, lockout tagout services, fall protection inspection, an annual safety management program, and sound level testing. Along with Rockwell's TUV training, we also offer arc flash certified training, a 3-hour refresher course in arc flash, fall protection classroom training, hearing conservation training, respiratory protection training, confined space training, forklift training, and lockout tagout. If you need to view some items in action or just want to troubleshoot your system, we have demo rooms available to try out almost any scenario. Thank you for attending today's webinar. If you have any questions or possible applications, please reach out to your local safety technician. We will post this webinar to our website. You will also receive an email with a link in case you want to go back to specific details. And here's our contact info. You will have time now to jot these down for your specific area.